In this video, I'm going to be looking at a number theory problem where I ask myself, why is it that if I take any two odd counting numbers and multiply them, why that product, it must also be odd as well. The key to this is knowing what do we mean by even and what do we mean by odd. For the counting numbers, even counting numbers have 2 as a prime factor, and all the odd numbers don't have 2 as a prime factor. So if we're thinking about the product a times b, if it were an even number, then that would mean that a times b would have to have 2 as a prime factor. But of course, that would only be possible if the first number had 2 as a prime factor, or if the second number had 2 as a prime factor. If both numbers are odd, if there are no 2's as prime factors inside of A, and there are no 2's as prime factors inside of B, then there will be no 2's as prime factors inside of A times B. Or in other words, if A is odd, has no 2's as prime factors, and if B is odd, there are no 2's as prime factors, then A times B will be odd. It will also have no 2's as its prime factors. So my answer then would be this. A times B is odd because since neither A nor B have 2 as a prime factor, then A times B won't have 2 as a prime factor either. Here we're actually using the fundamental theorem of arithmetic, the unique factorization theorem, the idea that we can take A, B, and A times B and break them down into products of primes, and that whatever the prime factors of A and B must be, those would also be the prime factors that show up in A times B. So if A doesn't have any 2's as prime factors, and if B doesn't have any 2's as prime factors, then neither would A times B.